Good afternoon. My name is Zhiyi, and I'm a PhD student from the Internet Intelligence Research Lab at Georgia Tech. Today, I'll be presenting on improving the inference of sibling autonomous systems. This is the joint work between myself and Zachary, Cecilia, and Alberto. The importance of our work is that we improved one of the fundamental Internet datasets, AS to organization mapping, which is essential for a number of research topics. We are all familiar with the concept of autonomous systems, or ASs. An AS is a clear unit of network that manages resources like devices, routers, and IP prefixes. Additionally, ASs determine the routing policies with other networks. However, this is not the whole picture of the Internet. Many of you have probably wondered how to determine which organization owns a specific AS, or how to identify every AS owned by a particular organization. In fact, such an organizational perspective is crucial to understand the Internet. Mapping from AS to organization is the only way to connect the AS layer research on Internet protocol and Internet traffic to real-world Internet events. Particularly, sibling ASs are ASs under the control of the same organization. In this example, we call these three ASs as siblings. Correctly inferring sibling ASs are important as their owner organization operates multiple networks, which is more likely to play a critical role on the Internet. This knowledge can be beneficial for a number of research topics. For instance, in the context of Internet censorship, identifying all sibling ASs owned by a responsible organization, such as a government-controlled ISP, is crucial to measure the impacts on end users. Despite the importance, it's surprising that in the 13 years since the pioneering work was published, no research efforts have been made to advance in this area. Even worse, both authoritative databases and the state-of-the-art dataset commonly used by researchers contain many inaccuracies in sibling relations. Our work has made three contributions. To our knowledge, this is the first work to systematically examine the inaccuracies in sibling relations. Based on our analysis, we have identified two types of inaccuracies and the corresponding root causes in the authoritative databases, which have cascading effects on the state-of-the-art dataset. Second, we have generated an improved dataset on sibling relations, in which we have corrected inferences related to more than 1,000 organizations, that is around 13% of total organizations with sibling ASs. Finally, we have designed and implemented an automatic approach for efficiently updating our improved dataset periodically. Before I explain our findings, we need a brief introduction on the background knowledge. The authoritative databases are WHOIS databases maintained by regional Internet registries. RIRs are authorities that manage the allocation and registration of Internet number resources such as AS numbers in a specific region of the world. The figure shows a resource allocation hierarchy where RIRs acquire resources from Internet Assigned Number Authority and then allocate to end users. Sometimes RIRs first allocate to local Internet registries or LIRs, which are typically ISPs, and allow them to make further sub-allocation. WHOIS databases record the information of delegated ASs, owner organizations, and the other objects. Unfortunately, RIRs employ different data structures for WHOIS databases. The left figure shows an example from ethnic WHOIS, where ethnic is the RIR in charge of the Asia-Pacific region. In this AS object, the organization ID serves as a link to its owner organization object. Well, the red figure is an instance from Iron Ruiz, which is in charge of the North American and Caribbean region. As we can see, the data structures are very different. Because of these issues, researchers prefer to use the state-of-the-art dataset, which is KDAS.org. It is organized using a uniform data structure specialized for AS.org mappings. It contains inferences based on Ruiz data and manual input. Similar to the ethnic Ruiz, KDA uses org ID to link ASs to the inferred owner organizations. KDA also integrates this dataset to their ASRank platform. When we search an AS number, we can see the same inferred organization, a list of sibling ASs under this organization, and a total count of the sibling ASs. Now, let me explain the steps that we took to achieve our first contribution, which is understanding the inaccuracies of sibling ASs. The first step was to understand the impact of Ruiz data on KDA's dataset. After comparing the two data sources, we found a high degree of similarity between them, with less than 1% of differences. Because KDA uses Ruiz data to make inferences, we should focus on the inaccuracies in Ruiz. After we made this decision, our next step was to discover potential inaccuracies. We leveraged ParentDB as an additional data source. ParentDB is a publicly available, user-maintained database where owners of ASs can directly maintain their information. Our intuition is that the discrepancies of sibling relations between ParentDB and KDA.AS.org are indications of potential inaccuracies in either of the two data sources. So we cross-checked the mappings and discovered 961 groups with discrepancies, involving around 1,600 organizations and 9,000 ASs. After discovering the potential inaccuracies, we carried out a manual research to collect the ground truth of ASs involved in these discrepancies. The research consists of contacting internet operators, reaching out to RIRs, searching on Google about organization relations, checking organization websites, and conducting keyword matching between names of ASs and organizations. During the process, we identified two types of inaccuracies and the corresponding root causes. The first type is incorrect sibling relations, and the second type is missing sibling relations. I will show you one example for each type and analyze the root causes. This is an example of incorrect sibling relation, where AS9426 is delegated by Ethnic, owned by Westpac Bank, which is a retail bank in Australia. However, both datasets map it to another organization, Syntel Optus, which is a big telecom company. This deviates from the actual ownership, where this AS is incorrectly inferred as one of the 63 sibling ASs under the telecom company, while in reality, it has only 2 sibling ASs owned by the bank. The root cause behind this is ethnic local internet registry issue, which is a problem only in the ethnic region. Different from other regions, RIRs in ethnic are responsible for applying AS numbers on behalf of their customers. As ethnic considers LIRs as resource holders of these ASs, they need to maintain Ruiz data and include their organization IDs in the org field, while putting the actual owner's name in the description field. On the other hand, KDA regards org ID as the only identifier of organization objects. Consequently, customer ASs of ethnic LIRs, which are owned by different end users, are incorrectly inferred as sibling ASs. And this is an example of the second type of inaccuracy. Here are two AWS ASs which should be siblings. However, Kata does not recognize it and maps them to different organization objects. Each organization object is inferred to only have 3 sibling ASs, while in reality, Amazon has 7 ASs as siblings. The root cause of it is multiple organization ID issue, which is a universal problem among all 5 IRs. This can occur for various reasons, such as the use of multiple org IDs for the subsidiaries and working groups, or the need of registering assets under different IRs, or acquisitions and mergers. As a result, when an organization uses more than one org IDs for ACSs, Kata's method is not able to discover all sibling assets. Now, after analyzing the root causes of quiz inaccuracies, let's look at our manual input dataset. Among 9,000 ASs involved in the potential inaccuracies, we corrected mappings for 1,028 organizations associated with around 4,000 ASs. The incorrect sibling inferences affects 15% of ASs, while missing sibling relations affects the rest 85% of ASs. Last but not least, we want to update our improved dataset to ensure its accuracy. However, it's not scalable to conduct the manual research for each new release of Kata's dataset. So, we have designed and implemented an automatic approach for efficiently updating our dataset. The approach attains a notable performance of reconstructing 95% of corrections in the manually improved dataset. Given the constraints of our limited time, I'm not going to explain details of this approach, but we have published our dataset to the research community, and we plan to update our dataset by running this approach periodically. As for future work, we are planning to further improve the accuracy of our inferences by leveraging text fields from ParentDB, such as the notes field. We also try to measure the reputation of ParentDB information to identify which ASs and organizations maintain more trustable information, which might help other research relying on ParentDB. If you are interested in our work, please refer to our paper and the GitHub repo of our improved dataset. That's all. Thank you all for your attention and patience.